All right, so here we are on the second day of factoring. We're factoring by grouping with 4 terms. Okay, we're starting this way because it turns out really nicely to be similar to what we've done earlier, just undoing the multiplication step. All right, so like we've talked about before you factor, you need to make sure of a couple things. Make sure the polynomial, first of all, is in standard form. Meaning like it's x cubed plus x squared plus x plus 1. It goes in descending order of exponents, okay? Next, you're going to pull out the GCF. If you forget this step, it is recoverable, but it gets messier, and you're more likely to make mistakes. So always try to pull out the GCF first. Not every polynomial factors. Some of them are prime. Just like there are prime numbers, there are prime polynomials, numbers that don't factor down further, at least not in whole numbers. Okay, so you can factor them so there's decimals, but then that gets really complicated and no one wants to know that. The biggest thing that you need to know before we start is your times tables. If you don't know those, this is going to get extra difficult. But if you know those, it's going to save you some time. It's going to be nice. All right, we're going to use these, multiply these using double distribution. Meaning we're going to have 2x squared times the x minus 4, and then we're going to have the 3 times the x minus 4. Notice that the x minus 4 repeats twice here, but it doesn't repeat twice when we're multiplying, when we have it written in that multiplication form. It's because that x minus 4 has been factored out. So now if I actually multiply these in, I get 2x cubed minus 8x plus 8x squared plus 3x minus 12. And you'll notice I have nothing to nicely combine because there's no like terms. So this is the final product of multiplying them. What we're going to be doing today is undoing that multiplication over and over and over again. All right? So right here, we're going to do that same thing. We're going to pull it out. And I'm going to show you on 1 what it looks like when we just do it using that double distribution. And on 2, I'm going to show you what it looks like when we undo that multiplication using the box method. Okay? So the first thing we need to look for is their greatest common factor. So there's a 1, a -5, a 2, and a -10. All of those don't have a greatest common factor. There's an x cubed, an x squared, an x, and then no x. No greatest common factor there. All right, so what we're going to first do is set this up so it's in 2 groups. So there's our first group. Here's our second group. Okay, the greatest common factor in our first group is going to be an x squared. So we're going to pull an x squared out, and then let's write what's left. So we've got an x minus 5 left. All right. So then I'm going to have plus, and what's the greatest common factor in the second one? A 2, because 2 and 10 are both even. All right, when I factor that out, all that's left is an x minus 5. Do you see how this repeats again? Do you remember me pointing that out in the first problem? All right, so now we're going to pull that x minus 5 off to the side, and we're going to pull it off to the right side because that's where it was in the first time. So we've got x minus 5, and then what's left is that x squared plus 2. Okay, and this is all nicely factored all the way down to its basic components. All right, let's go ahead and do that again, but this time I'm going to be using box method. But the first thing we always need to do is look for that greatest common factor. Is there a greatest common factor? So we've got a 14, a 77, an 8, and a 44. So I don't see a greatest common factor between all of them because 77's only factors are 7 and 11, and 11 doesn't go into 14, and 7 doesn't go into 44. So there's no greatest common factor. So what I'm going to do now is I'm going to set this up in my box. So I'm going to put the 14n cubed in the upper left, the negative 77n squared in the upper right, 8n in the lower left, and the negative 44 in the lower right. The most important parts is that the highest degree is in the upper left and the lowest degree is in the bottom right. Remember that this is degree 0 because this is n to the 0 power, but we don't write that because that's silly. All right, so now I'm going to pull out the greatest common factors between the columns and the rows. So I'm going to write what would have been there that multiplied into that box. So my greatest common factor along the bottom between an 8 and a negative 44 is actually a 4. And my greatest common factor along the top between a 14 and a 77 is a 7. And then an n cubed and an n squared, this is going to be an n squared. So this piece becomes 7n squared plus 4. So my second piece, so the greatest common factor between 8n and 14n cubed, that's going to have an n in it. Then 8 and 14 have a 2 in common. Now is 2 times 7 14? Is n times n squared n cubed? Perfect, we're on the right track. Now what about 2 times 4? Is that 8? And n times no n is 1n. All right, so then the next part has a 2n at the beginning. All right, so this last one, notice that they're both negative. That means I'm going to pull out a negative here. You always pull out the sign that is the first number. So we pulled out the negative, okay? And then we've got a 77 and a 44. The greatest number in common they have is an 11. Because the 44 has no n, we're going to have no n that we can pull out. So it's 2n minus 11. Now let's check that real quick. So it's negative 11 times 7n squared, negative 77n squared. Yes. What about negative 11 times 4? Is that negative 44? Yes. So that's how we know we've done it correctly. All right, so you guys now have a couple that you need to do on your own. So you've got this one to do on your own and this one to do on your own. All right? And that one. So there's technically 3. You've got this. I know you do. So once you finish those 3, go ahead and write your recap and you are all done.